Hi everybody. I know it's been a while since we've done a lesson, but good news is school's gonna end soon. We only have a few more lessons to go. We're starting Unit 14, which is integration. And today we're going to talk about antiderivatives. And they are a little bit what they sound like. They're not against derivatives, but they're working derivatives backwards. So we're going to start out with finding the derivative of some functions. And I want to remind you of this notation, dy dx. We didn't use it a lot, and I regret that now that we're getting in this far into the course because now we kind of need to use it. So I feel the need, it's going to be in the problems, and I want to know that you know what it means. So what that is the derivative of y, the function, with respect to the x variable. Okay? In higher levels of calculus, you'll have multiple variables, and you'll be questioning, what are you finding the derivative in terms of which variable? Okay? Because you can only do one at a time. And in this do now, when you look at it, and I hope you pause and take these derivatives, you'll see that you get the same derivative over and over again there. Why? Because the derivative of these terms right here are all zero. Derivatives of constants are zero. Okay, so when we're taking the antiderivative, we're going to have an issue because there's infinite possibilities of what something could be the derivative of. It could be the derivative of, in other words, 2x could be the derivative of any x squared plus something or minus something, right? So x squared plus 4, x squared plus 11, x squared plus pi. Oh, I wrote that twice. I'm so creative here. X squared plus 146. Doesn't matter. Or x squared minus 246. It could be the derivative of any of those. So in general, 2x is the derivative of any function x squared with something added or subtracted to it, which we say x squared plus a constant. X squared plus a constant. An antiderivative is the term for finding what function is something the derivative of. It's really working backwards in derivatives. How do we find an antiderivative? Well, we know the antiderivative of 2x is x squared plus c, where c is a constant, because we figured that out just now. We did it by trial and error. We took the derivative of multiple functions and saw all of their derivatives come out to 2x. So now we know that 2x is the antiderivative of x squared plus anything, even negatives. Okay, so some notation we have to be aware of first. Okay, the first notation is this elongated S that you're going to see throughout the rest of this lesson. And that symbol is an integral symbol. Okay, and that's the symbol to indicate that we're taking the antiderivative or we're evaluating an integral. Okay, so the problems that we just talked about would look like this. The antiderivative, the antiderivative or the infinite integral of 2x with respect to x equals x squared plus something. And that something could be nothing, but we don't know what it is, so we have to write it there. What are some antiderivatives that you know? Don't panic. Since antiderivatives is just working backwards, then if you know the derivative, you know the antiderivative. Right? So let's go to trig, your favorite place. What is the antiderivative of cosine? In other words, what function gives you cosine as the derivative? Okay, you know this. Derivative of sine is cosine. So the antiderivative of cosine is sine plus a constant. Because whenever we take that antiderivative, we have to include a constant. Okay, so what about the antiderivative of the negative sign. The antiderivative of the negative sign would be the cosine plus a constant. Okay, so those are the ones we've memorized. What do we do with the power rule? How are we going to undo the power rule? Okay, so we write out the power rule. Power rule is the derivative of a function with respect to x of x to the n is n, exponent comes down in front as coefficient, times x to the power 1 less than you had before, x minus 1. To undo this, this is the formula we're going to use. Okay? 1 over n plus 1 equals n plus 1. 1 over n plus 1 times x to the n plus 1 plus the constant. You subtracted in the power rule, so now you add. Now, why is this over 1? Well, I think you're going to see it from an example what happens here, okay? Here's x cubed. What's the antiderivative of x cubed? Well, when we took a derivative, we took the exponent, brought it in the front, remember? And think this, think right here. You took the derivative, you brought the exponent down and decreased it by 1. So this exponent is now a 3. So it's going to become a 4, right? That we got. And what that means, a 4 came down in front. Where is it? It's not here. It's not there. Okay, so we're going to say 1/4. And then by saying that 1/4, that's why it's gone, because it's divided out. And we get x to the 4th times 1/4, which is x to the 4th over 4, plus the constant. Don't forget the constant. Now, I know that's overwhelming. That takes a lot to digest. So I want you to think about it backwards. What's the derivative of what I got? What's the derivative of x to the 4th over 4? Okay, the 4 is going to come down in the front, right? And that exponent's going to come down as a coefficient and be decreased by 1. We're going to get 4x cubed right here, 4x cubed. Leave the over 4. And the derivative of a constant is 0. So the 4's are going to cancel, and we're going to be left with x cubed. Now pause this and think about that. If you think about that, the derivative of that gets you this, then the antiderivative of that, of x cubed, has to give you this. So pause and digest it. Okay? Now, if a variable has a coefficient, it can be factored out before you take the antiderivative. This will make things much easier for you with the fraction part. Then you're just going to have some fun reducing. Okay, what is the antiderivative of 6x squared? So we're going to take the 6, that's a coefficient. We're going to take it in front of the antiderivative sign. And when we're doing the antiderivative with respect to x, we only really want to deal with the x term. Okay? So we're going to get 6 times whatever the antiderivative is of x squared. Okay. Now, you're going to use this sort of formula here. See it? That's what you're going to use. That's what I used here. So I have n equals 2 here. So I do 6 times 1 over 2 plus 1. I'm adding to the exponent, and I'm adding to the exponent, okay? I'm adding it in the denominator here and here, plus c. So that comes out to 6 times 1/3 x cubed plus c. Now here's where you're going to get interesting things happening. You have cancellation here. 6 times 1/3 is 2, right? So we're going to end up with 2 times x cubed plus 6 times c. Now, 6 times c is just 6 times a constant, which just makes it a bigger constant. So you don't even have to worry about the distributing of that 6. You can just write it as C. Okay. So the antiderivative of 6x squared is 2x cubed plus c. Don't forget the constant every time. The reason I say that is because we always learn from our mistakes. I had a calc test senior year of high school on antiderivatives, and I was killing it. I killed it. I did everything. I did all this stuff so good. I was champion. I had negatives, fractions, all kinds of stuff going on. I never wrote the constants. I got every question wrong. Oh, yeah, from a teacher who didn't give any partial credit. So I got a big fat 0 and had to retake the test and redo it all, but it's writing constants at the end. So don't forget the constants. I'm just trying to help you out. And when you hear this, hopefully you'll remember. All right. If you're evaluating an integral of a sum or a difference, you're going to take the integral of each term. Just like the derivative of a sum or difference is the derivative of each term, the antiderivative is the same thing. So when you have a problem like this, the antiderivative of 4x squared minus 5x, you're going to do the antiderivative of 4x squared and the antiderivative of the 5x and subtract them. And here, my arrow notation, you can see I'm going to do what we just did with the 6. I'm going to take those coefficients out of the way so I can deal with just my variable, okay? So I end up with 4 times. Now this is going up, not down, because we're taking the antiderivative, so it's 1/3 x cubed, okay, that's here, minus 5 times 1/2 x squared, because this has an exponent of 1 here. So I'm going up 1, 1/2 x squared, okay, plus constant. I forgot it again. Okay, so this one doesn't cancel pretty. Of course not, because I made this one up. The ones I took from other resources canceled nicely. This one doesn't cancel, but it's good to see how it works. This is what it ends up looking like. Kind of an ugly function to take its derivative of, but also a reminder that no variables in the denominator, so these wouldn't be quotient rule derivatives. You would be taking 4/3 as your coefficient here, doing 3 times 4/3, which is 4 x squared, minus the 2 comes down, 2 times 5/2 is 5x. And this goes to 0, okay? Now, there's some practice problems going from number 4 to 11. You can see my answers for some of them here. I will post this answer key. I hope this was an informative lesson on antiderivatives. Please email me or text me on Remind if you need help with antiderivatives.